improved performances of coated glass and the spread of insulated glazing units allowed in the past years the development of several applications related to the building facade. The aim of this video is to introduce the main glass applications in facade, describing different materials and systems adopted in each solution to highlight their technological characteristics and their main strengths and drawbacks. Firstly, it is important to distinguish between traditional window and curtain walls. The former are usually applied to limited areas of the building envelope and are embedded in the opaque wall, while the latter usually constitute the wall facade or large areas of the building envelope. Traditional windows are manufactured and installed as a single element within the opaque wall, thanks to an external frame which can be realized in many different materials. These materials range from traditional wooden profile to PVC, aluminium, steel, or a combination of the previous ones, as better described later. The interface between glass and frames is usually solved thanks to the adoption of EPDM gaskets that allow to accommodate the tolerances and to assure the air and water tightness. Instead, the curtain walls are classified depending on their technology as stick systems or first-generation curtain wall facade, unitized systems or second-generation curtain wall, or as structural glass facade. The stick and the unitized systems are evolutions of the traditional windows, as they are both based on the glass frame gaskets scheme, but they are designed to cover larger areas. Basically, the difference between stick and unitized systems regards their level of prefabrication and their installation. Finally, the structural glass facade differs from the previous ones as it allows to create an all-glass facade where the envelope load-bearing structure is completely hidden behind the glass. Looking more in detail at the different window frames, they are constituted by a fixed frame, which represents the interface with the wall, and, in case of openable windows, a movable frame which hosts the glass panel. The most traditional solutions are based on wooden frames which are characterized by a low conductivity, but they do not have any air cavity, resulting in high overall thermal transmittances. On the contrary, PVC frames can reach low thermal transmittances thanks to a series of air cavities created within the frame. Similarly, also aluminium and steel profiles define internal air cavities that reduces the overall U value. Nevertheless, to avoid heat losses resulting from the high conductivity of metal frames, usually the profiles are interrupted by a thermal break, highlighted in red in this figure, with a different material. Using aluminium or steel profiles allow to improve the mechanical behavior of the frame, reducing, consequently, their thickness. Finally, the combined frames couple the functionality of the material adopted as main frame with the aesthetic of another material applied as external cover. Moving to the first generation curtain wall, the stick systems are characterized by a frame composed by mullions, vertical elements, and transoms, horizontal elements. The facade is installed directly on site, fixing the mullions directly to the building structure, usually but not necessarily on the slab, through dedicated brackets. Then the transoms are connected directly to the mullions. Once the wall frame grid is set, the glass panels or the IGUs can be installed on the frame from outside, fixing the panel through dedicated pressure plates mechanically fixed to the grid. Finally, the pressure plates and the mechanical fixing are masked thanks to the cover caps. The main advantages of stick systems rely on their transport and cost efficiency. Nonetheless, the quality control is difficult due to the on-site installation and they strongly rely on on-site workmanship. The unitized facades start from the same concepts described for the stick systems, but implement a higher degree of prefabrication. To reduce the work on site, each module of the facade already comes complete with frames, glazing and gaskets pre-assembled by the manufacturer and are installed on site as a single component, often called unit. This approach allows also, when required, to use the structural sealants to connect the glass to the frame, avoiding the mechanical fixing and the following cover caps, resulting in a fully glazed effect. The facade is composed placing each module side by side thanks to additional external gaskets that assure the air and water tightness between the modules of the envelope. Considering that each module is complete and do not require any additional work, these facades can be mounted from the inside without any external scaffolding. It follows that, unlike the stick systems, the unitized facade allows to reduce the installation time and cost and increase the quality control which can be conducted in a production warehouse. On the other hand, the prefabrication of the modules implies limited on-site adjustments and higher production and shipping costs. Finally, the structural glass facade is composed of an interior load-bearing structure, which can be realized in many ways, and a glass pane that is directly connected to this structure without using continuous gaskets and external pressure plates or caps, as described in the stick or unitized systems. The inner structure can range from glass mullions to steel fins, cables, rods or aluminum mullions, while the outer glazed facade can be realized using monolithic laminated, double-glazed or even triple-glazed insulating glazing units. The air and water tightness are guaranteed thanks to the use of high-performance gaskets and sealants. The connections between structure and glazed panel are often realized through bolted point fixings, mainly using the so-called spider connections, but also alternative adhesive connections can be realized based on the use of specific gluing techniques. The design of these facades provides a good protection for the load-bearing structure, an easy-to-clean external surface, and a seamless continuous glazed aesthetic, but, on the other hand, they are more expensive. Thanks to the main facade technologies described in this video, the use of glass can be implemented in different ways in our building design to fulfill very different architectural and technical requirements. Depending on the aesthetic result, performance required, geometry and key feature of the building, the designer can choose the most suitable solution in a wide range of technological options.